Well, welcome to our new module. So we've already done core, we've finished off core. We're now moving into matrices. We're going to do 3 modules here. This is just a quick bit of revision. There are 6 modules to pick in VCE, and we are picking 3 of them. As a school, we're going to teach 3. You're welcome to choose any of the 6, but I would recommend you choose the 3 that we teach, because we haven't taught the other ones. So this is one of the later modules. This one's called matrices. I'm going to spend the next little while working on this one. So matrices are really just a different way to represent information. So we've already looked at, in core we've looked at scatter plots and histograms and bar charts, stem and leaf plots, all this different sort of type of stuff. What we're going to look at now is a really different way to represent a table. So here's an example of a table. Dogs, cats, so there are, say, 18 people that had 1 dog, and 165 people that had 2 dogs, and 190 people that had 3 dogs, and so on, and there's the cats. And here you can see, obviously the dogs and the cats, no one owns both. There's not really a column for that, but that's fine. We'll ignore the flaw in the table. So you could change this table into a matrix. So it's exactly the same information, it's just represented in a different way. Just like you could put exactly the same information in a dot plot as you could in a stem and leaf plot. And it would look different, and it would be more useful probably to put it in a dot plot or put it in a stem and leaf plot, depending on what you wanted to do with it. It'd be really hard to, or really easy to find shape in a stem and leaf plot, just like it's really easy to do some things with matrices. So I turned this table into this matrix. And we called it matrix A. Often we call them A because A is the first letter of the alphabet, it's easy. And then if we make a second one, usually we call it B. But it doesn't really matter what you call it. You can call it anything you want. It's just easier, I think, to call it A. So when we're talking about matrices, always we talk about rows and then columns. So it doesn't matter what we're talking about. If we're talking about elements, if we're talking about the order, if we're talking about a particular part of a matrix or multiplying matrices, always we do the rows first. So rows, columns. So rows by columns, or if we're talking about an element, we write the row first, the column second. Always rows and then columns. So please don't ever. It never comes up in matrices where the column is talked about first. So always we talk about the rows, and that's these ones this way, and then the columns second. So always, 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 that is always the case. If you're having trouble remembering what's a row and what's a column, I think it's easy to think of like a Roman Colosseum or something, and they have like columns in a Roman Colosseum, and they go up and down, like the big, the Parthenon has big columns, Roman columns made out of cement. So that's like what the columns look like. And then similarly rows, like in a classroom for instance. We sit in rows in a classroom and they go across the room. So rows going across and columns going up and down. If you forget, I reckon that's an easy way to remember. So always rows first, columns second. Which is ironic because I just told you what a column was before a row was. Please forgive me. So here's this matrix again, and I've just listed here, this is the first row and the second column. So that's my element just there. I'll talk about elements a bit more in a minute. So the first thing we want to think about is the order of a matrix. We did this in Year 11, so you should have a vague recollection unless you didn't do Year 11 with us. The order of a matrix refers to its size, so it's just a way to write its size. So we put that in brackets, and we write the number of the row, and then we write the times, like by, and then the number of the column. So that's row by column. So for instance, if we want to find the order of matrix A, B and C, here's my matrix A, here's my 6 elements in that. It's got 3 rows and it's got 2 columns. So it's a 3 by 2 matrix. Rows, columns. Always rows first, columns second. 3 rows, 2 columns. Same with B. So B has 3 rows and 4 columns. So let me just fill in that one there. I'm going to write the order. 3 rows, 1, 2, 3. 1, 2, 3, 4 columns. Always rows first, columns second. So the order is 3 by 4. If you're writing the order, you don't have to write 3 rows, 4 columns. You just have to write this bit here. That's the 3 by 4 matrix. So same with this one. I'm sure you could do this one. You might be able to beat me to it. It has 2 rows and 2 columns. So I'll just write that here. 2 rows, 2 columns. So the order is a 2 by 2. 2 rows by 2 columns. A 2 by 2 matrix. So we found the order of A, B and C. That's that question done. There are some specific kinds of matrices And we don't really see them very much until we get into transition matrices, which is sort of the end of this module. But it's useful to know what they are now because they might come up anyway. So matrices, if they only have one row, so they only have one that goes this way, one row, then we call that a row matrix. I've just called this one M. It doesn't have to be M if it's going to be a row matrix. I've just picked a random letter for us instead of A. So here's my row matrix, and it doesn't matter how many go this way, just one row. So here we go. The order is 1 by 5 in this case. So that always has to be 1. Same with the column matrix, pretty much exactly the same thing, only here we have a column. So a matrix that only has one column is a column matrix. So I've called this one T, because that sounded like a fun idea. It's got one column, and it happens to have 3 rows. So the order is 3 by 1. So this will always be 1 in a column matrix, and this will change. Could be 4, 5, 1, 2, whatever. Square matrices, I bet you can probably guess, have to be square. So if it's 1 by 1 as its order, or 2 by 2 as its order, or 3 by 3, that's 3 rows, 3 columns, or 4 by 4, if it's in a square shape, then that's a square matrix. We see square matrices a lot when we're multiplying, because we usually multiply 2 by 2 matrices. So here's an example of a 2 by 2 matrix. I call this one X for the fun of it. So 2 rows, 2 columns, so the order is 2 by 2, and they're the same, so it's square. You can see it's square, the numbers will tell you it's square, whatever's easier for you. Last but not least is the elements in a matrix. So all of these different numbers that we see in all the different matrices, each of them is called an element. So there is an element here, 12, there's an element here, 15, an element here, 17, that's another element, so there's 4 elements in this one. Here's an element 1, an element 3, an element 5, an element 16. So in this one there's also 4 elements. So that's a square matrix as well, just for trivia's sake, and I've called that one A, just because A seemed like a good letter. So each of those numbers is called an element. We can label them specifically. We list see this matrix is called matrix A, so I've listed it A, second row, first column. So this number here, 5, is in the second row and the first column. I might just circle that for us. The second row and the first column. So I've written element A, 2, 1, second row, first column in A matrix is 5. Now I've just written second row, first column. So if I asked you, for instance, for element 1, 2, that would be the first row and the second column, that would be number 3 there. Or in here, if I asked you for element 1, 1, that would be the first row and the first column, so that would be element 1, 1. So then I'd write X, 1, 1 instead of A, 1, 1, because that's my X matrix. Just like if we flip way back to this one here, for instance, here's my M matrix, so I would call element first row, fourth column, this one here, first row, fourth column, I'd call that M1, 4, first row, fourth column, and a little m for that one, because that's labelled M, that matrix. That's pretty much it for the introduction to matrices.